Okay, now we're going to look at applications of exponential functions. So some applications have to do with half-life and doubling time. We can go beyond that, but this is a good start. Okay, so basically what you have is a function that looks like this. P of t equals p naught a times a to the t over k. Now, p, I'm representing that, the function as p of t because it's usually stands for population. You could use other forms as well. You could say f or whatever. P's subscript 0 is like in sequences and series. It's the first term, okay, or the 0th term in this one. So when time equals 0, this is the first value. Okay, so to define this all, for half-life, a is 1/2. Double time, a would be 2. Okay, so doubling, multiplying by 2. Halving, multiplying by half. P0 is the initial value when t equals 0. And k equals the time for half-life or doubling of whatever it is. Okay, so it could be number of rabbits in a conservation area. What does it take to double the population? It could be the value of a vehicle. What does it take? How much time does it take to get half of the value of the vehicle? Okay, so k represents half the time it takes to get to half or double. So as a quick example, so if you've got money doubles in 3 years, okay, so this is the initial amount of money that you have, and it doubles in 3 years, so you're going to use a equal to 2 because it's a doubling problem. So 2 to the t over k. Well, if k equaled 3, which it would because it doubles in 3 years, doubling time, then when you plug in 3 for t, you're going to get 3 over 3, which is 1. So the initial amount times 2 to the 1, well, it's times 2, so that would double it. Okay? If it halves in 3 years, well, then this base would be half, and k would be 3, and whatever the original amount was, we multiplied by 1/2. Okay? So here's a problem. If it takes Cece 3.5 years to double her investment of $37, how much will she have in 10 years? Okay, so there's a couple ways of looking. There's a number of questions you could ask here. How much would she have in 3.5 years? Well, if it takes 3.5 years to double, she'd have double 37, which would be 74. How much money would she have in 14 years? Well, that would be 4 of these. So it wouldn't be 4 times 37, it would be 2 to the 4 times 37. Okay? Because it doubles every 3.5 years, so every 3.5 years you multiply by 2. So you do that 4 times, so 2 to the 4 times 37. So those are questions you can work out without having a formula. But if you ask for 10 years, well, 10 is not a multiple of 3.5. So we're going to write down the function. So P of t equals 37 times 2 to the t over 3.5. 3.5 is a doubling time, so that's the k value. Okay? And 37 is the initial amount. Now you want to find out what that's going to be at 10 years. Well, you're going to plug in 10 for t. And you get $268.09. Okay? Another question would be this one. Robin's $470,000 car depreciates to half its value every 2.5 years. Okay, one question would be, what is it worth in 7 years? Again, 7 is not a multiple of 2.5, so we're going to have to write down the function. And then, when will the car be worth $100,000? Okay, so in this formula up here, there's a number of things you can ask for. If you know all of this and you can sub in t and solve for that, it's great. But what if you know this and you don't know t? Well, then you have to solve for an exponent. Or you don't know k. Or you don't know p naught. Okay, so you could be asked to solve for any of those. All right, so here's how we're going to do this. So for the first one, we set up the function. Okay, P of t equals 470,000 times 1/2 to the t over 2.5. Plug in 7, plug in, and you get the number $67,486.03. Okay, so it's a half-life problem, so you have to have the base of 1/2 for that one. Okay. Now, in the part B, you want to know what t is when p of t is 100,000. So you can put 100,000 in for p of t, cancel out all the zeros, divide, and then in grade 11 you're supposed to be able to guess and check this. But if you don't want to, here is a quick log formula for you to use to solve for an exponent. And when we do that, we get 5.58 years. Okay. Another question here, it's not necessarily a half-life or doubling time, so Avery invests $350 at 10% interest per year, compounded annually. So every year she gets 10% of what was previously there. Okay, when will she have $1,000? Well, in this case, every year she gets 110% of what she had. Starts with 350, then multiply it by 1.1. And then every year after that, you get it again. So it's 1.1 to the t instead of 2 or 1/2. Okay? So you put in $1,000 because you still want to find out what t is. Then you could use this log rule again, or guess and check. And you get 11.01 years. Okay? So those are some applications of exponential functions.